Assalamu alaikum dear students. Hope you are fine, you are safe, and you are utilizing this time very perfectly, very effectively. In the previous video lecture we did question number 7. It was actually the converse of midpoint theorem, for which you have studied in your previous class. In today's video lecture it is just the midpoint theorem. In class 9th there is a proof for midpoint theorem that is different. We have to use the concept of parallelogram, angles, etc., but here we have to use the converse of Thales theorem to prove the midpoint theorem. First of all, I will make you understand that what is the midpoint theorem. You have read it in your previous classes. If ABC is a triangle, if we form a midpoint of any two sides of triangle, say AB and AC, suppose D and E, the line segment DE is so formed according to the midpoint theorem. DE, it is parallel to the third side, that is BC, and is equal to half of it. Here we have to only show that DE is parallel to BC. In that case, at that point of time, we use different strategy to prove it. But here we are in the triangles of this class of class 10th. We have to use the converse of Thales theorem. It is mentioned question number 8. It is mentioned here, so we have to prove it. We will prove it with the help of converse of Thales theorem, that it is a parallel to third side. So what we are given a triangle ABC, and D and E are the midpoints of AB and AC. To prove DE parallel BC, we will prove it. So first of all, what is given, we will write the given. We will write D and E are the midpoints of sides AB and AC of triangle ABC. To prove, we have to prove that DE parallel BC. This is exactly in case of midpoint theorem. This is the midpoint theorem. Line segment joining any two midpoints of sides of triangle is parallel to third side and is equal to half of it. We have to only show that this is parallel to BC. So I again repeat it, that in that class we prove it with a different strategy, but here we will use the Thales theorem, converse of Thales theorem. Look, we will write in triangle, since we'll directly write proof. AD equals DB. Can we write it? AD equals DB. Why? Because D is midpoint of AB. D is midpoint of AB. So divide it. We will write it AD by DB. This equals 1. Name this first. If you divide both sides by DB, you will get 1. AD by DB, this equals 1. Similarly here, AE equals EC. Why? Because E is midpoint. So AE by EC, this equals 1. Name this second. So from first and second, if you look, AD by DB, this equals 1. AE by EC, this is also equal to 1. So from first and second we get AD by DB equals AE by EC. From first and second we get AD by DB equals AE by EC. Because both are equal to 1, so their LHS are equal. So we got AD by DB equals AE by EC. Recall the converse of Thales theorem, that if a line segment divides the any two sides of triangle in the same ratio, then the line segment must be parallel to the third side. So we will write in triangle ABC, AD by DB equals AE by EC. Why? Because we have proved it above. So therefore DE parallel BC. Why? Reason being, by converse of Thales theorem. Please, while writing in the examination, mention the statement of the theorem here. If a line segment and divides the any two sides of triangle in the same ratio, it is parallel to the third side. So this was all about in this question. It is actually you have read it in your previous classes, but at that point of time we have proved it with a different way, in a different strategy. Here you have to use the Thales theorem and converse of Thales theorem to prove it. I hope you have understood it very well. If you still find any difficulty in understanding this, please let me know that. Thank you, class.